Okay, we're going to start this morning's lecture by balancing equations. So what I need for you to do is get out a notebook and a writing utensil, and we're going to do some problems. I have three equations that I have here in Microsoft Paint, and I'd like for you to write them down. Now, if you'll remember, first rule of balancing equations is to make sure that you have written down the equation correctly. I can't tell you how many times I've sat down to balance an equation and I've transposed a subscript, or I've forgotten one, or I've written the first half of the equation from problem 1 and the second half of the equation from problem 2, and can never get them to balance. Now, one of the things that I like to do first and foremost is look and see if there's any polyatomic ions. Now, the easiest way to spot polys are if there are 3 or more capital letters in a compound. So if you look at sodium phosphate, Na3PO4, there are 3 uppercase letters. So I know that there's at least one polyatomic ion in there, and it is phosphate. And I go ahead and put parentheses around phosphate. It's much easier to balance phosphate if we treat it as if it is its own element. And I go through the rest of mine as well, rest of the compounds, and there's hydroxide, and there's a hydroxide, and there's a phosphate. And if you're doing the boxes method, this is where you would put boxes around all your compounds. But right now I'm going to work with the trial and error method. So I will look for the biggest, the baddest, and the ugliest looking compound to start with. That's always going to be the one that's got the most subscripts, the most letters, and just it looks like it's the most intimidating one. So I'm going to start here with Na3PO4, sodium phosphate. And I look and I see I have 3 sodiums on the left and I have 1 on the right. Well, I know I need to add coefficients out in front over here to get them to equal. So I'm going to add a 3 here. That means I now have 3 sodiums and I have 3 hydroxides. But I started over here. So I've my sodiums, now they balance. And I've got my phosphate. I have 1 phosphate on the left and I have 1 phosphate on the right, so they're completely balanced. There's nothing I need to do to the left side of the equation just yet. Now I look at my next compound. I have 1 potassium on the left, but now I have 3 on the right. So I know I'm going to need to add some coefficients over here on the left. I'm going to add a 3, so that gives me 3 potassiums and 3 hydroxides. So if I do a quick inventory, 3 sodiums, 3 sodiums, 3 hydroxides, 3 hydroxides, 3 potassiums, and 1 phosphate. So now my equation, I just go back and I insert ones into the problem, and it's done. Going on to the second problem. Lead 2 hydroxide plus hydrochloric acid yields water and lead 2 chloride. Well, in looking at this problem, if you'll remember one of the asterisks that I put in there, that if you have a hydroxide on one side and water on the other, that it is completely fine to go through and rewrite your water as HOH. So I'm going to rewrite this as hydrogen hydroxide. Now I do this mainly because for me it's easier to balance hydrogens with hydrogens and hydroxides with hydroxides. takes away part of my stress level when going through and balancing some pretty tough equations. So I go through and I pick the biggest, the baddest, the ugliest. Well, I'm going to start over here on the left, lead hydroxide. Well, I have one lead over here on the left, and I have one on the right. So those two balance. I don't have to do anything. But I have two hydroxides on the left, and I only have one on the right. So I'm going to have to add a coefficient. I want my numbers to be equal, so I'm going to add a 2. So I've added my 2 over here, so now I have 2 hydrogens and 2 hydroxides. Well, I only have one hydrogen on the left, so I know I need to add a coefficient out in front. So now I have 2 hydrogens, which match the 2 hydrogens on the right, but now I have 2 chlorides. But if I look over on the right, I also have 2 chlorides. So everything balances. So I go through and I add my 1s, and we're done with that one. So let's scroll down to the third equation. And this one, in looking at it, does not have any polyatomic ions. So there's no parentheses that I need to add. But I do need to pick the biggest, the baddest, and the ugliest to start with. I'm going to start with Li2Se, lithium selenide. Well, I have 2 lithiums on the left, and I have 2 on the right. Good to go. There's nothing I need to do there. But I go to selenium, and I have 1 on the left, and I have 2 on the right. So I'm going to add a coefficient of 2. But me adding that 2 has actually messed up my lithium numbers now. So I have 2 times 2, which is 4 lithiums, but only 2 on the right. So I'm going to add a coefficient of 2 on this side as well. So now I have 4 lithiums and 4 lithiums, 2 selenium, 2 selenium. But now I have 2 oxygens on the right. I look back over at the left, and I also have 2 oxygens, so those are balanced. And then 1 sulfur on the left and 1 sulfur on the right. And since everything's balanced, I put in my 1s, and I am done. Alright, let's try one more equation, okay? I have a combustion reaction here, and I know it's a combustion reaction because I have a hydrocarbon plus an oxidizer, which is oxygen, and my 2 products are carbon dioxide and water. So I'm going to pick the biggest, the baddest, the ugliest compound to start with. C3H8, I think that's pretty big. So I've got a 3 on the left, and I have a 1 on the right. I'm going to put my 3 out here. I have 8 hydrogens on the left, and I have 2 on the right. So what times 2 will give me 8? That would be 4. And now all I have left are my oxygens. Remember, we leave our hydrogens and our oxygens until last to balance. So I've got 2 oxygens on the left, and let's see, I've got 3 times 2 is 6, plus 4 is 10. So what times 2 will give me 10? And that would be a 5. So my balanced equation is, coefficients are 1, 5, 3, and 4. So now that I've worked through a couple of these equations for you, so we've worked 4 problems, and I think you're ready to try some, or hopefully working these 4 problems may have sparked some questions that you need to come see me about. So you're free to rewatch the video, walk through the steps again. You have your worksheets in front of you, and I would love to answer any questions. So just raise your hand and let me know how I can help you. Good luck, my children.